All right, stats class. So we're going to continue with probability, and from this point, things are going to get they're going to be less sort of. I'm going to talk less about like real application and more about theoretical probability. And these are going to be the types of questions that are remaining on your practice sheet. And that's going to have a lot of different probability rules. So you will be writing quite a bit in this video. And I'm not going to make this a super long video. I always say that, right? But I really don't plan on doing that. I'm going to talk about a few questions in the problem set. Because I want to make sure that we're working away at those. There's a lot of questions in there. At this point, you should be able to work 1 through 21. My cat's going crazy. Let's go ahead and talk about where we left off. The last thing that we did was, let's do the intro. All right, so we talked about a sample space and how to build a probability model. We did that with adding two dice together. But we want to go ahead and write down a definition for what's called an event. Okay, because we're going to see a lot of notation in here that we're going to have to use moving forward. It just simplifies the amount of writing that we have to do. So we're going to start with the definition of event. So in your notes, go ahead and write this down. Event. What is an event? Well, we have our definition right here, and I'll go ahead and pause it, and you can get that written. All right, so an event is any collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters like A, B, C, so on. We can name it anything we want. But normally you'll see probability of, you have event A and event B. That's typically how a lot of questions look. So I have that bottom part there that you should have written. If A is any event, we write its probability as P parentheses A. Okay, so you're going to see that notation quite a bit. Usually the event is defined beforehand in the problem. So we had this last time. Remember, I had asked, my cat is wild right now. We had asked, what's the probability of rolling a 4? Well, that was my event. If I had defined getting a 4 as A, I'd say, what's the probability of A? And it would have worked that way. Here they have an example where they're saying, we want to know A is the sum of the two dice is 5, and we have our probability table. You should have that in your notes, the probability model that we made, and you'll see that 5 is 4 out of 36. Okay, 4 out of 36 is what we got. And then we can do this event down here. Sum is not 5. Okay, we're going to talk about this down here. This is how they did that. It's everything other than 5. So you can either add all those up or you can subtract by 1. That's going to be an important rule that we're going to be writing down. We call that the complement. Okay, so forewarning before I change the slide here, there's about to be a lot of writing that you're going to have to do over the next 2 slides. I apologize about that, but it is just going to be part of this. I need you to have these rules. It is going to help you when you are answering some of these questions. So these rules are very important. Yes, there's a lot of yellow here. I need to slide this over to the side here. Can I make this large? Does that help? To put my camera like right there. Okay, let's go through. We'll present these. Hold up. I've highlighted all these yellows. Okay, first off, the probability of any event. So any time, and there will be questions on this test where you got to determine what is a legitimate probability. So first off, the probability of any event is a number between 0 and 1. Next, all possible outcomes together must have a sum of exactly 1. If we look at our probability model for the rolling 2 dice, if we add all those up, that 1 out of 36, 2 out of 36, 3, 4, 5, 6, 5, 4, 3, 2, 1, if we add all those up, we're going to get 36. So it's 36 out of 36. So it has to add to 1. That's important. You will have a question where that's something that you're going to look at and say, okay, this is not a legitimate probability model. Next, if all outcomes in the sample space are equally likely, the probability that event A occurs can be found by using the formula number of outcomes corresponding to event A, total number of outcomes in the sample space. Okay, quite a bit to write there. But again, I'm going to pause all this at the end so that you can write it. Next bullet point, the probability that an event does not occur is 1 minus the probability the event does occur. So that was this bottom part here, this very last part way down there. 1 minus that. That's called the complement rule, but we'll talk about that more. Next, if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. Okay, this is a very important rule. Understanding, like reading a question and saying, oh, these don't have anything in common. Okay, there are no common outcomes. That means that you can just add the probabilities of either one of them happening. I want you to, let me zoom out here. I want you to actually underline this and bold it, double underline it if you can. That rule right there is very important. Go back to it. The or statement, that one or the other. So we have these words or and that mean so much in this chapter. They mean so much when you're reading some of these questions. Now, we have a special term for events that have no outcomes in common, and that is the events are mutually exclusive or disjoint. If they have no outcomes in common, they can never occur at the same time. So this word mutually exclusive or disjoint is how you'll see it in a lot of text. If they have no outcomes in common, make sure that you underline, this is your definition here, so you can write that. But if they have no outcomes in common, the probability that they occur at the same time, it's not possible. Okay? So we're going to look at an example in a second, but I am going to go ahead and pause the video and make sure that you had plenty of time to write this. If you need to rewind after you've written it to go back through them one more time, I would recommend that, just to make sure that at least you have a fundamental understanding of them. So let's pause the video here. All right, so you've written that. Now, let's rewrite them one more time, but in a simplified way. Obviously, you're like, oh, Mr. Woods, why are you doing this to me? Why couldn't you give me the simple version earlier? Well, because a lot of this wouldn't make any sense if I presented it first. Okay, now you don't have to write this whole thing again in the center, but this is every bullet point you just wrote down. We don't have the mutually exclusive in there, but it's every bullet point you just wrote down. So at the top, you can write, see up here where it says summarize? So you can say summarize the basic probability rules right there. Okay, that can be sort of the title on here. And we have these rules that we're gonna look at. So this is the same as bullet point. Remember, any event has to be between 0 and 1, and it can equal 0 or 1. So that's why we have the less than, equal, greater than, equal to symbols here for any event. Next bullet point, if S is the sample space, then in a probability model, probability of that happening is 1. That means all the probabilities have to add up to 1. Okay? We don't really actually need this one. Let me get rid of this. We have our rule. We don't really need it. It's the same exact rule. Okay? That's if there's equally likely outcomes, like rolling a 6-sided die. Next, the complement rule. Very important. If you're saying this out loud, like you want to find not this event, we have this symbol here, the little C. I want everybody to look at that. This little C here. Whenever you see a little C, that means it's the complement. Let me actually add something else in here. Also shown as a, so you can have this little, they call it A prime. That could be the complement there. So make sure you add that to your definition. There may be some worksheets that we look at that have that. The problem set has the C's, or it should. And you need to understand that this means not A. Let's put that phonic in there as well. This is super important. Say not A. Okay, not that event. Okay? That's how you need to understand those. Very important. Okay? Very important. Next, addition rule for mutually exclusive events. Now, you will actually get this formula on the test. So, is this rule important to memorize? Not necessarily the formula, but the understanding of what's happening is very important. Okay? If A and B are mutually exclusive, what does mutually exclusive mean? It means they cannot occur at the same time. The probability of either one of those happening is the summation of those events. So, example, let's talk about this. Can I roll, let's go back to these dice, right? And I should have saved my notes. So, is it possible to roll, we have 36 outcomes rolling 2 dice. Is it possible to roll both a 6 and a 4? I take 2 dice, roll them. Could the outcome be both a 4 and a 5 at the same time? Hopefully that's not confusing to you, but when you roll the dice, you're either going to get you're going to get exactly one number. You are not going to get 2 possible summations. It's going to be one value that the 2 numbers add to. Okay, so let me make sure that that's clear, because it sounds like, yeah, Mr. Woods, you can get 2 numbers because you always get 2 numbers. No, we add them first. Every time you add them, you get one value. So that could be a 4, it could be a 5, but it couldn't be both at the same time. You're getting an exact value. So that's an example of mutually exclusive events. I cannot roll and get a 12 and a 10 at the same time. Okay, it's going to be one or the other. So that's why we call them mutually exclusive. Okay, so when we go down here to this event, let's go back. This is that rule. What did we do with those probabilities? Probability of rolling a 4 or a 6. We have that in our notes. Well, we just added the probabilities together, and that should have made sense. But now we're moving into this more a less like practical approach. We're sort of thinking a little bit more abstractly here. We don't need like the probability models to answer these questions. So let's look at a couple items on the practice problem set. So number 21 is a definition. An assignment of probabilities must obey which of the following. You are using these rules. So read these rules, pick the best answer that's in number 21. Okay? Make sure you're using those. Now, 22, let's go ahead and look at this one here. 22 is what we're talking about when we have these ideas of disjoint. Okay, so we're using that rule immediately. Disjoint. That means A and B can't happen at the same time. So what is the probability that both events occur at the same time? This isn't an or statement. This is, I want both of them to happen. This is like saying, I'm rolling, probability of getting a 6 is 0.4. Probability of getting a 7 is 0.5. That could never happen at the same time. Like, you're going to get one or the other. So the probability that they happen at the same time is 0. That's based off of this rule here. Right there. Probability of A and B down at the bottom that I've highlighted. Okay? So that's that idea. This can be very confusing for a lot of students. Probability, I will say that it's kind of difficult. We're going to skip 23 for now. We haven't talked about independent yet, so we'll come back to that. But you have a lot of these different scenarios here, where here 25 is complement rule. 24 is using these definitions up here. It has to add to exactly 1. That's the sample space, right? So what does yellow have to be? Well, it has to be the number that makes it add to 1. Here's this or statement right here. Since these could not occur at the same time, you're drawing one M&M, right? They can't occur together, so you got to think about that one. 27, you're using the rules. You're using these rules here to help you determine the answers on these. Looking at this, okay, you have the or statement. So a lot of these, you can answer quite a bit of these now and probably reason through them based on these rules. Here is a definition here. If the knowledge that event A occurs, okay, cannot occur. Yeah, you have a definition. So knowing 1 has happened, the second event cannot occur. We still need to define independent. We're going to get to that, but we're not quite ready yet. Let's just say that you can work through 28 now. I'm not going to go much further than that. I said this would be a shorter lesson. You've already written a ton, but you should be able to work 21 through 28. You may be able to get 29, but we don't know what independent is yet, and that's a super important topic. Like, we've sort of discussed it. Where did we write that down? Not here. It was another PowerPoint. It was this one. Let's pull that back up just to close out. We talked about the idea of independent, which is past outcomes do not influence the likelihood of individual outcomes occurring in the future. So we discussed that as independence, that law of averages right there. So we're not ready to go on just yet. I wanted this to be a short lesson to finish out this week. But again, if you have any questions, like please, if you start answering these, I really want y'all to try to practice these, and you don't feel you're not sure about an answer, send me an email. Let me see what you're thinking. These are great practice problems to help you understand probability a little bit better. But send me those questions. Send me answer choices. Let me check those. Okay. So we're gonna go ahead and stop here.